In this video, we have the integral of x plus 2 over 2x plus 3. You might consider partial fractions, but we only have one function here. It's not simplified, but you can do it at least three ways. Will a u substitution work? Yes, it would. If you let u equal to 2x plus 3 and do the standard procedure here and transform the integral into the variable u, the integration would be fairly easy. So that's one way you can approach it. Another way you can do it, because the degree of the numerator is not less than the degree of the denominator, you could go ahead and use long division and divide the numerator by the denominator, and you'll get a quotient and a remainder. Take the remainder over the divisor and integrate the two integrals. That's another way to do it. And what I'm going to do now is just an option that I use instead of long division. So what I'm going to do is rewrite the numerator as 2x plus 4. And that's legal as long as I put a 1/2 out here. Because 1/2 times 2x gives me the x, 1/2 times 4 gives me the 2. So I haven't really changed it. And then I've got the 2x plus 3, the denominator. So I just rewrote the integral. It's still the same integral though. Now I'm going to rewrite the numerator again, the 2x plus 3 plus 1. That's over 2x plus 3. Put your dx here. And just basic division of polynomials here. I'm going to take the numerator and divide by the denominator. So I'm just going to say, well, 2x, break it up into two integrals. In other words, 2x plus 3 over 2x plus 3, that's 1. So let's do it this way. Still got the 1/2 here, multiplying everything there. Okay, two integrals then. So the first integral then would be the integral of 2x plus 3 over 2x plus 3. That's just going to be 1. So I get that. And then it's plus, the 1 is divided by 2x plus 3 dx. I want to remind you, if anytime you have the integral of, say, a constant, not a variable, but a constant, 2, 3, or 4, okay, k, and the denominator has to be linear form, ax plus b. That k over ax plus b, and then this is a dx here. If you do a u substitution and let the u equal to ax plus b, this will come out to ln of the absolute value of the denominator plus the constant of integration. And if this is 1 here, then this would just be a 1 here. But if it's some other number k, that answer right here would just be multiplied by k over this, the a. Derivative of the denominator is a. That's where that comes from. So it's going to be like this. That would be the answer. Anytime you have anything like this, as long as it's constant in the numerator, and the denominator ax plus b, where a and b are just constants, plain numbers. If you got a square here, that's not going to work. But that's your answer. So for this one here, integral of 1 with respect to x, that's going to be x, and then you multiply that by 1/2. So I get 1/2 x, or x over 2 if you want. And then it's plus. Now, you can just do the substitution here, that u equal to 2x plus 3, and you get the same answer. But I'm just telling you that there is a formula that you can, I've derived it in some other videos. Common practice that you can use this. So for this one here, this is just going to be, the k here is 1, so this will be 1. And the a is 2, so this will be 1/2 here, but then you're multiplying by 1/2, so this will be 1/4. And then it's the natural log of absolute value of 2x plus 3. And then it's plus the constant of integration. So 1/2 x plus 1/4 times the natural log of the absolute value of 2x plus 3 plus the constant of integration. That's your answer here. Doing it this way. Again, if you use the substitution u equal 2x plus 3 and work it just like we do all problems involving u substitution, you should get this answer. Or if you use long division here, instead of doing what I did here and multiplying the numerator by 2 and then multiplying by 1/2, didn't change it. And then breaking it down this way, 3x and 4, you do it long division, just like other problems that have been done, you should get the same answer. Now, one thing that I want to point out to you is sometimes you're working a problem by whatever method. Let's say, for example, we did this problem another way, and we got everything we have here, except suppose it was a plus 3. So we had 1/2 x plus 1/4 ln of 2x plus 3, constant of integration, c, and we also had an extra 3 here. Is that the same answer? Yes, it is. And that happens sometimes when you work a problem by another method. You might have a constant left over, but remember c is a constant. So all you would do is the first integration, you could call it c1, and then you can, for the final one, you can call it c, but the c is the sum of c1 and this constant 3. But in this case, we don't have that extra constant. So that's your solution. 1/2 x plus 1/4 ln of absolute 2x plus 3 plus the constant of integration. Thanks for watching. We'll see you next time.